Hello, hello. How you guys doing? How was your weekend? Where's this gonna go? Over there. Okay. All right. Hello. So yeah, I'm gonna continue with this today. Did a little bit of this off stream the other day, a little bit, and I confused the hell out of myself because the file names were too similar. So it was one of those cases of you know, modifying one file, thinking it was a different file, and then wondering why my changes aren't taking effect. Happens more often than it should for me, honestly. Carl _ how you doing? Hello. I'm doing okay. A little tired today, but I'm doing all right. I'll get through it. Right. So what the fuck am I looking at here? When we left off last time, I rediscovered, because I don't want to say discovered, because I kind of discovered some bullshit shenanigans that one of these discs is doing. So we were going through this right here, the slow ROM, the slowdown stuff for the ROM QD, which is the ROM dumped to a disk. And I was looking at the actual dump for that, and one thing that had puzzled me before. So if we go over to, I think it's this one right here. TS list. Okay, I need to put ROMs. There it is. So these are the files on that dumped ROM. This one, the one I'm looking at right here is for Donkey Kong 3. That's the one I dumped from hardware. Anyway, so we got some PPU stuff, right? Name table, character ROM, sure. The actual ROM from the cartridge. And then this is the, I kind of want to say bootloader, but that's, I don't know if that's really correct. That's the bootstrap, I guess. And part of that, if I open it up, this guy here, and then go to the bottom, and then entry. So that copies a bunch of crap around, right? So it copies from hex 5800, right? To is that right? No, 7. Huh? What the fuck? No, hang on. I got that note's wrong. That's 58 plus 28. No? Huh? 5/8 plus 2/8 equals 8. Okay. Wait, that is right then. Okay, never mind. But yeah, so this copy is starting at, you know, 5800, right? And it does it copy all this? No, it doesn't. Interesting. So it doesn't copy all of that. But the second loop down here copies from D800 to whatever, right? But you'll notice that this ROM, this disk doesn't contain anything at D800. It starts at DC00. And what we realized last time is D800 is from a different goddamn ROM. That's from this guy. That's where that D800 is from. So we were stepping through this the other day. And did my music stop? No, okay, that goes. And when looking through this, I realized that, is it this one? Yes, it's this one. All right, entry, and then goes to start. Yeah, start. It does all of its stuff, and then it jumps to a reset vector. This jumps to the BIOS reset vector for the Famicom disk system. So it loads itself into memory, and then essentially does a soft reset of the console to get you to insert the other disk. So when this other disk loads, this data isn't unloaded. It's still there. So so the dump, what do I want to say? Accounts for, Bridgewater, how you doing? Accounts for the slow ROM that may have been loaded beforehand. Good afternoon, how you doing? And then after so this is copying some stuff around so it can actually, you know, run the ROM from I hate how there's like very few new lines in this freaking file. I wonder if I can add some somehow. But yeah, so this is it has to set up some stuff and shuffle things around to be able to run a cartridge game from a disk, right? And this is part of it, right? After it does some copies, it goes to, you know, its entry point post copy, and that is right there. And the first thing it does, well, it resets the stack, so we're starting fresh, killing just nuking the stack. Brayden taking nourishment, that's what he used to say. Nice. And the first thing it does is it checks to see if the slow ROM has been loaded. So this right here, the var slow check, that's 7BFE. 7BFE, is that? We're not going to see that in here. I thought we were going to see that in here. That's the pre-copy, that's why. I need the post-copy, I think. Post-copy. Really? 7B? $7B. $FE? Now I'm wondering where that's actually copied. Where that's actually set, rather. But at any rate, it looks for I2. And if it doesn't find it, it means the slow ROM hasn't been loaded. But if it has, it jumps to it, right? This setup slow. That's the pre-copies. That's not. Well, no. Okay, so that would have been copied in from. This is where it gets confusing. So now that source code, or that source code, that binary was copied from the other disk by this disk to a different address space than what I'm expecting. Yeah, it's copying it to 7800. Yeah. So the pre-copy for this guy, this one, Zeta Shaw, how you doing? Welcome. Pre-copy here. So the start of this, hello, it's going. I'm just getting started today. Hang on, let me open up the pre-copy for this. So yeah, there's like two versions of each source file here because it copies shit around immediately, which just immediately confuses everything. Oh, there's the alert. It took a second. Hey guys, what were you working on today? Yeah, so wait, does this actually store it lower? Then no, it doesn't store it any lower. Okay. Ugh. Goodness. So for those coming in, I am working on reverse engineering a thing called the Souseiki Fammy. It's a really weird attachment thing for the Famicom that goes in between the Famicom and the Famicom disk system. Let me get a picture of the thing real quick. No, that's the wrong directory for that. This directory. And then this, and then there. That's what it looks like. Well, this is what it looks like, you know, a part of everything. So yeah, it's this device right here that allows you to take certain ROMs, certain cartridges, and back them up to a disk via the Famicom disk system. And then it also allows you to load that disk and play it from the disk without the ROM available. Plugged in, whatever. Really neat piece of hardware. And it jumps through a few hoops to get his job done. And I'm trying to untangle said hoops. Because so for the Famicom disk system, games have to be typically specifically ported to it, right? Because there's a BIOS for the Famicom disk system that facilitates reading and writing from the disks, basically, and handles a bunch of other like graphics loading routines and input handling, you know, controller input handling and stuff like that. But that occupies a sizable chunk of ROM space from hex E1000 up, right? And that's an issue because when you're trying to run, when you run a cartridge game, the cartridge is mapped there, right? So in order to run a cartridge game from disk, you need to get that BIOS out of the way. And a lot of the moving around is to facilitate moving the BIOS out of the way. So this guy here has some extra RAM that can replace that entire range of E1000 to the end of address space, or half of that from like F1000 to the end of address space. So yeah, so it's got to copy stuff around. Like once you load up the disk, and all that copy logic has to, you know, already be on there. And there's also the slow ROMs, which are the slow-mo ROMs essentially, right? Mapper support is kind of limited. What was the capacity? Yeah, the mapper support is basically none. It only supports, from what I understand, NROM games, or any game that would that doesn't swap out the top. Well, no, actually, it has to only. It can only really support NROM games because that has to fit onto a disk and be able to be loaded into memory entirely, and like to be able to stay to be able to have it entirely in memory at one time. So I'm like, hey, welcome. Which means it only has that 32K available for 32 plus the however much for like 8K, or no, a little more than that for the character ROM. Yeah, so it's not a lot. The slow ROMs, so there's a few flavors of the slow ROMs. They're all on separate disks, because of course they are. And looking through this, by the way, I want to try my hand at rewriting these as a single disk, because a lot of them have like copy pasted code out the nose. Welcome, by the way, Matt Birds and Van Kluver. Am I saying that right? Thank you for the follow. Appreciate that. What is even this? I don't know. It's a new feature thing that Twitch added to, I don't know, boost engagement or some bullshit. I don't know. I'm not complaining about it. It's neat, I guess. I don't know. But yeah, so reversing these things. So I've obviously dumped all these disks, and I've been reverse engineering, disassembling them, seeing how they tick. And there's a significant amount of copy pasted code, and in a few of these, it looks like there's a bunch of dead code as well. It can be ignored. Yeah, it can be ignored. And I think that dead code is just code from a different one of these disks, right? So I'm fairly confident that I'd be able to take the functionality from a bunch of these and like combine them into like 1 or 2 disks, especially for the slow ROMs, right? Because the slow ROMs are all basically the same thing, with some tweaks here and there specific to either a ROM source, a quick disk source, a disk source, or a ROM dumped to a quick disk, right? They're all more or less the same, just slightly tweaked here and there. Because it has to be set up just a little bit differently, to get the same outcome, right? I haven't looked at the BB-RAM one yet, which is for dumping a cartridge's save RAM to disk, which I think is very useful, right? Like especially if like it's battery backed and you need to replace the battery or what have you, you know, or just having more backups of your save game or whatever. So that's I haven't gone through this one yet. And the one for dumping the disk, I haven't actually really dug into yet. I have to sneeze. Hang on. God damn. Okay. Whew. Anyway. But yeah, so reverse engineering this thing is challenging to say the least, because no emulator currently supports the device. I was able to get partial support in Messen by hacking on it a little bit. I was actually looking at the Messen source code a little earlier today to see how hard it would be to implement a little bit more stuff. So for a lot of this stuff, it requires like switching the actual disk, right? So for the slow ROM, right? The slow ROM for QD, right? Which is this side of this disk, right? This one, you pop it in, right? And it loads up the slow-mo. Let me briefly explain what the slow-mo is. So on a bunch of third-party controllers, there's like a slow-mo switch or button or whatever, and maybe like a dial, right? It's supposed to slow down the game that you're playing so it's easier or something, right? And the way that those controllers handle it, because they only have access to the controller input, right, is to basically spam the start button. And sometimes you have a little dial to adjust how fast it spams the dial button. Did this really just say Soromo? Slow-mo, yeah. Pretty much, yep. The Chad Gaming Stack, yeah. Dude, man, how you doing? And so spamming the start button does technically work. It might also give you a seizure. Perfect example. Actually, I can just switch that to ROM, power that up over here. So this is Donkey Kong. This is the cartridge that I'm using to test multiple things. This is one I have the dump of, right? So playing this, if you hit the pause button, it flashes the screen, right? Which, yeah, I guess it slows it down, right? But it might also give you a seizure. Whereas with the slow-mo discs, it interrupts the NMI or the V-blank, right? Which doesn't have any flashing, and is a lot smoother. It's a lot nicer to work with, nicer to play with, right? And it doesn't and it'll in theory work better with games that have a menu, right? So this game has just pause, right? But other games like Mega Man, for instance, when you hit start, it brings up a freaking menu, and And that doesn't really work with those slow-mo controllers. And only good for games that just halt the game when you pause. Yeah. Without audio delay. Right. Now, so due to how the slow-mo for these work, the audio will be incorrect. But not necessarily. Well, it'd be slower, kind of, but not like out of tune, right? Because it's basically just interrupting every frame and basically giving a lag frame every other frame or however, right? Where it doesn't do any processing for the game. Yeah, so it's just loading the notes slower is all it's doing. The notes still sound the same. It's just they are coming at you slower. Which is, it sounds interesting. But yeah, but like I said, it works a lot better than spamming the pause button or spamming start. But yeah, so untangling the dome crickets, yeah, basically untangling the shenanigans that this stuff pulls with copying shit around and overwriting parts of the ROM and overwriting parts of the BIOS, and it's just, whoa. It depends. It depends on how the audio engine is actually coded. So if there's two kind of ways you can write an audio engine. You can write one that takes advantage of the hardware's envelopes, which a lot of the earlier games did, right? Like I think Donkey Kong 3 does. Or you can write an audio engine to write new values every frame with constant volume, right? Which gives you a lot more flexibility for the envelopes that you can have, right? And more later games would have that, right? So it would handle those differently. I mean, they'd still be slow, but slow to update. But they'd sound different in different ways. Yeah. But yeah, so untangling this stuff is a task, because it's not only just code from one disk, it's code from two separate disks, right? At least. And that's kind of like where I gave up on Friday. Was when I realized that. When I realized that, oh no, this is jumping somewhere else. So today I want to see if I can figure out how to properly disassemble what this is jumping to, so I can read it as it would be executed, right? Because I cannot yet emulate this portion of it, right? Because if I open up code messen 2 tmux cd over to bin Linux release. Okay, so this is a patched version of Messen that I have that allows for basically just gives more RAM to the disk system. It does not implement any of the register stuff. Excuse me. So it allows me to step through it, kind of, right? Up until the point. Okay, so this is a slow for QD, right? So we're just gonna run it through real quick. Oh, yeah, breakpoint. Get rid of that. Eject discard. All right, so I popped in the slow disk. It loaded up and it wants me to eject it. Cool. All right, so I'm gonna go over here. I'm gonna hit eject. Okay, set slow level. So I'm gonna set it down to 4, and I'm gonna hit start. You'll notice it wants me to insert another disk card. Now, on hardware, that would be the game I want to play. Unfortunately, in Messen, I can't load another disk without resetting the system, right? So if I open up another disk, so I'm gonna hit open here, and ASM stuff, ROMs, Donkey Kong. If I do this, and I have another look at the memory viewer, so all that stuff was loaded into the 5,000 range. You'll notice nothing's here anymore. It unloaded everything, because I loaded a new disk. So I got to figure out a way to, I don't know, either patch that in or manually load in some stuff. Export. Oh, wait a minute. Hang on. Maybe I can do this. File, recent files. Put a bit. Let me actually try this. Hang on. Eject this card. Yep. Game. Eject. Set slow level. 4. Start. Export. Save that there. I don't know if I'll be able, I probably won't be able to import that though. And then we're going to load up this. Yep. But I can't import that. How many don't welcome? I love that. In synthesizers, there are common envelope types, AD, AR, ADSR, and then there are uncommon envelope types, like the 8 parameter thing that Casio sees. Sociopathogen, hello, how you doing? What hex or disassembler is this? So I'm working with 2 separate pieces of kit. This emulator is Messen 2 specifically. These are all the windows and all that, the debugger of the assembler. This stuff over here, this is all generated via the CC65 compiler suite. There's a disassembler in that suite. So this over here is one of the configuration files to tell it how kind of to disassemble it. Yeah, what different addresses are and names and labels and all that kind of stuff. Oh yeah, hang on. I see ads. Give me 1 second. Or 50 seconds, I guess. But yeah, I'll get back to you. I'll get back to you once the ads are done. I wonder why import's disabled though. Not lit. What the hell? UI debugger? No. UI Windows. I even forgot you run ads. Yeah, well, so running the ads turns off the pre-rolls, which is a big thing, right? Because pre-rolls will kill a stream. They'll just murder it, right? Because who wants to watch 2 minutes of ads as soon as they click somebody? Nobody. But yeah, so I use 2 separate pieces of software that I haven't written. I've written a bunch of utilities to help me along my journey. This here is Messen 2. This is the emulator that I use that has a fantastic debugger. Fantastic debugger. And this is all generated by the disassembler in the CC65 assembler suite, compiler suite, whatever. There's a disassembler in there, DA65. But yeah, so that's what I'm using. And like I said, I've written a bunch of my own tools. Like I wrote one to convert the disassembler configuration into label files for Messen. So if I LSL labels, so these are label files that I can just import into Messen, so I can get proper labels in the debugger. Yeah. And I don't even have all of them. Hang on, vim make file. I'm missing this stuff. Yoink. Paste. Labels. MLB. Beautiful. And that's this right here. That's this is I'm messing this stuff. So yeah, this is one of the utilities that I wrote. This is the one that takes a configuration file and then writes out a label file for use in Messen. There it goes. So when I go over here, debugger, and I can just file. Oh, is it because it's a disk system thing where I can't like load and save ROMs or some shit? Dumb. Import labels, visit, select. Booty beep. So now, and I also had to remove the default labels that Messen puts in. I don't like how Messen handles the default labels. They're all hard coded in the source. I'd much rather them be in an MLB file or something, you know, something that's loaded on runtime instead of something that's compiled in. But let me add breakpoint. Anything execution from 5,000 to DFFF. Go. Spent a lot of time in the past thinking compilers were some black magic shit because of all the shitty economic bugs in BS language community. Yeah. They are. I mean, they're almost black magic. You know, they're up there. They're close. Or lecture tokenizer in 3 hours. Yeah. So the other day, in fact, that's what my converter does. It's a lecture tokenizer thing. That I closed out of. All right, hang on. Let me go over to it. What? Where the hell is this? Go DASM labels here. So this is a very shitty parser lecture, to put it nicely. I only like parse what I fucking need. There are 3 different types of parser for different shit. Nice. Yeah, I wrote this in like 2 days. But so this only parses out like what I need, right? So that means it only parses out ranges. Which are these guys, and labels, which are these guys. It doesn't care about global crap. And it doesn't care about some other stuff that I don't use in here. What was it? Segments, and I think there's something else. Segment and That's how it's supposed to be. No. DS65. Flashbang warning. Segments and includes, I think. Yeah, because these, I don't even know what the hell this is going on about. I'm not sure the syntax of that one. 7 lectures about what parsing is academically defined, and then use a regex function fucking parser to generate a parser. Yeah. So for the longest time, I shied away from actually diving in to a lecture parser, because I just saw it as a massive, daunting task, right? Then again, one of the first things I tried to do with it was parse a dumb fuck language named PLB. That one's got all kinds of bullshit wrong with it, that language. And I immediately ran into issues with that one, because I know what the fuck I was doing. But actually, after writing this, I'm like, oh, that wasn't too bad. Maybe I can try again with the PLB stuff. So PLB is COBOL but worse, basically. It does some stupid shit with its comments, which is where I struggled. Yeah, I think I've got a better grasp on it now. Right. Most these people will go over the code generation and optimization like it's nothing. Yeah. The Dragon Book has like 700 pages for parsing. Jesus Christ. 700 pages for parsing. God damn. What are you doing in 700 pages, right? I don't even think this has 700 lines. Yeah, this doesn't even have 700 lines in this parser. Yeah. But yeah, so for PLB, like the syntax is batshit insane. So for something like, Go or whatever, right? It's got a very rigid syntax, right? The secret of life, right? So for, whenever you see for, it's a loop thing. You can't have that as a variable, right? Anytime there's an open bracket or whatever, that's a new scope or what have you, For PLB, it's each statement starts with a command, a verb. And then the format of the rest of the line depends on which verb you choose. So the length and format of that fucking line changes for every single operation in a language, and it's terrible. And then when you've passed all the possible arguments to the verb, everything else after that is a comment. Full stop. No delimiter. It's terrible. TCL, one of the worst languages, but the coolest syntax ever. TCL. I've heard of TCL, I think. Sounds familiar. What's the syntax look like? Oh, it's not bad. That ain't too bad. Yeah, so for this right here, this is a valid source file for PLB. There's no such thing as a reserved word, because of course there isn't. So depending on where something is in the line, it changes its meaning. Everything is fixed width and fixed length, strings and arrays, and it's painful. When a hash map, you write a space separated string. It's not typed at all. PLB is barely typed. Barely. Functions. Everything's a string. Yeah. Most everything here is a string. Most everything. Not quite everything, but most everything. Like numbers. These are strings right here. The form, that's a string. Technically, kind of, sort of. That one is implied as a string. Shut up. But yeah, this language is dumb. It's really stupid. I hate it so much. And this is for context, this is the language I use in my day job. So I am frequently scrolling through a 30,000 line file to fix something that broke. Strongly type everything's a string. But yeah, so I started writing another parser for this guy, and I'm approaching it differently than I have in the past, to see if you know, I can get any further this time. And so far, so good. Imagine this in my for syntax equals 4, so my for syntax is another word for 4. Yeah, macros. Yeah. Advertise, they all just convert to each other implicitly. Yeah, so there's some type conversion in PLB as well. Conversion, coercion, maybe, but kind of. I don't know. It's weird. You know, it's weird and I hate it. But anyway, I need to hit the bathroom quick, so I'll actually be right back. Don't go anywhere. I'm back. So it's the -1, -2, -3, 0, 1, 2, 3. What? Excuse me? That's disgusting. It's disgusting. Anyway, back to this. Okay, so I want to sell, like I said before, I want to get that, into a spot that is readable, I guess. I don't know. So I need give me here. Okay, this is gonna be oops. Slow ROM QD post ROM copy. Yoink. Paste like that. And bins. I need the ROM QD file 1. I think file 1, right? Yes, file 1. Okay. You like that? No. You like that? Okay. Give me let's do the pre-copy one. Let's yank some of this stuff, paste it there. Slow ROM QD file 1 bin. Start address is going to be 78. And I need only a little bit of it, actually. So this actually copies... How much does it copy? 7 pages. All right, so... 1792. Okay. Well, anyway, so in global, argument column, comment column, comment, CPU, hex offset. Offsets the labels are output in hex. Input name, input offset. So no, input size. That's what I want. Input size. $0,700. Okay. Post ROM copy. I need to fix that error. Okay, so this guy right here is the start of the slow setup. Label adder 7800 name SF slow setup. That's not how you spell setup. That's how you spell setup. Okay. I'm not sure exactly what that is. The reset. We're gonna have 2 labels for those. 7 F70 and 1. var 7F70 and 1. Okay. That's a lot of data. See, there's so much like extra space in these things. I could totally like rewrite this to be on one disk, I think. Oh. I'm still trying to wrap my head around this. Annoying it's the last week of my home country before moving again. Well, you moved to a bunch of different places, right? You lived in the UK for a little while, right? So it's not like it's the first time. Okay, then there's this again. 7, 6. That's 6. And that is size 8, I guess. Come on. Yeah. Really, that it's been 8 months since I've been outside the country. Okay, so store those. That's a loop. Yeah, sure. Load up that. No, don't branch to that. What the fuck are you branching to that? God damn it. Okay, well. Range, start of something. I don't know what yet. End at 7C05. That's not a $sign. That's not a $sign either. There it is. Type code. All right, where the hell is this start? Because it's modified code. Woo! So much of it, goddammit. I don't know about that actually. I'm not sure about this. This might not be. This might actually might be data. We're gonna say it's code though for now. We're gonna see what it's doing. That's data. Okay, you know what? Let's just start from here actually. We can change it later if we need. So that is 7BE0. Okay. Label adder 7BFD CV7BFD. Yep. 1/16 of my screen. Oh my goodness, that is tiny. All right, so this changes the high byte of this. For whatever the hell reason. What the fuck? Where is this call from? Okay, so that might not even be code, actually. Huh? Wait a minute. So we're gonna actually undo what we just did there. Okay, so that's just a loop there. Load up this. Store it there. Load up this. Store it there. And then JS already here. Label. I can paste. This is going to be 7F73. 73 size 2. Nope, 7.2. There it goes. JS are already here. FA and FB. Seven FA. Load store, load store. 3978. Okay. The hell's that an ASCII? Is like 9, right? Where the hell? Why the hell? There's a good table. Never mind. There's a good table. Never mind. It's like, come on. Just really. I don't want to go to fucking Pinterest. Hex 3. 9 is 9. Yep. And then 78. 9x. 9x? All right, well, it backs up whatever it was. 7896. So it backs it up and rewrites it. Sure. Ew. All right, so jumping over here. So that's gonna be all code. Yoink. Paste. 7C14 to 7C3D at least. No, a little further. All this stuff. Oh, this is the this is gonna be the IRQ then, isn't it? Maybe? I don't know if this is actually used here. Okay. And then jump over to there. Fucking where? What? DC 36. Go to hell. Branch equal. Yeah, all right. I forget. Was this one? No. Okay, so that's going to end at 7C4F. 4F, that's code. Make.
I'm afraid I can't say.
This is going to be data ending at 7C13. Starting at way up here somewhere, I think. I'm just gonna go ahead and say it's gonna start way up here, way above all this. Um, 7969. Looks like I might have gotten it right. Label 7BFC, 7BFC. Size 2. It's not really a variable, it's just a data technically. Dat. How about that? It's over here. ASL E01F. What in the fuck? Wait a minute. No. Huh? That can't be right. 7C14. Is that... Hang on. Is that overwritten by... The DK ROM? Yeah. Yeah, it is. It is. It fucking is! Ah! Did I have the input size wrong on this? I had the input size wrong on this, didn't I? No, I didn't. Originally, no, because I didn't account for the shit that was overwritten. Fuck. All right. Hex. D8. No, DC minus D8 is 4. I hate that so much. So much. Because then after that... Yeah, okay. I think all that code's crap. Or no, that's probably actually the new IRQ has got to be in there. 7C14. There's... Okay, okay. All right. So it jumps to there afterwards. Okay, so it jumps the setup. So it sets some shit up. So this has to be the original IRQ, and then the new IRQ 7839. Not IRQ, NMI. Seven, 8, 3, 9. Oh, Jesus. This is some good article, but I was faced with someone who basically says different people have different things and they don't know why. Different people like different things. Who would have thought? God. All right. So this is the slow NMI. What the fuck is this? Huh? Okay. So 7C14, 7C. 7C isn't in here anymore. That's not in here anymore. I'm going to reuse that. That's going to go up to 7968. 68. And it's going to start... Let's get started at the very top. 7800. Did I get that right? 7896. 68. 7968. Yeah, okay. Make. Okay. Something fucky's going on here. Force C. What? Oh, there's an error. 1700 already fine. What? Oh, fucking range. Oh my god. Start. End. Jesus. Type. Code. How the hell did I screw that up that badly? There it goes. There we go. Okay. Thank you, Val. Appreciate that. All right. 7896. Label adder 7896. Name CV 7896. Size 2. There we go. Because that is the original NMI. So let's actually do that. Original NMI. So no, this is going to be the FDS NMI. $7839 is the slow NMI. So this label adder 822 name SF setup replace NMI. And then this I'm naming it no slow over here, but that's not really correct. Kind of is, but I kind of want both these on the same. Well, not both of them, but I kind of want to use the same config for both of these, or I want to. Can I actually? I mean, yes, but having more than one config input for these. I mean, it'd just be post copy dot config dot temp that one and labels.kfg and rum qt like that, which will have all of this shit in it. And this is gonna get rid of, I'm gonna get rid of all that. Yoink, paste. Nope. Like that. Yoink, paste. This one's gonna be for this guy. I need to rename that, but whatever. Yoink. Paste. Make. Right, okay. 7800 already defined. This guy, 78. There it is. Why? Oops. I should have done that one, shouldn't I have? Nope, because I didn't name that anything, apparently. TASM, post copy, yeah. 7C14. It's right there. Oh, because I didn't. Grab this, put it over here. SF QD from QD start. There we go. What the hell is this? Why is that? What the hell did I do? 7C. No, 7C14. Huh? 7C. 1-3. No. 6-9 to 7 B BFF. There we go. That's better. Okay. 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 All right. Confusing as hell. Goddamn. Oh, God. I hate it. All right. I don't know if I want to bother disassembling all this crap. I guess I'm gonna have to, I guess, right? This guy, jump to that. I guess I don't have to. Branch equal. What's that? Start and select, I think. So that's A, B, start, select. Yeah. Otherwise, this is just nothing else. Still sort, load, clear out those. What the fuck are these variables actually used for? Oh boy. Okay, so that's a lookup table for flashing the LED. Okay. Okay. 1, 2, 3, 4, 5, 6, 7, 8. I should know this, but I don't. 16 times 8, 128. Okay, yep. Post-ROM copy. Yeah, I'll put it in here. Label adder 7969. Name tool. $128. Table LED blink. Yeah. Hand that or it with that. So what the hell is this? Is that like speed or some shit? Might be speed. All right, so it resets it, turns off the LED and a bunch of other crap. In fact, actually, what does that actually do? So that's just 024. Mirroring? Mirroring? That's 124. Oh, bank mirroring, not name table mirroring, just bank mirroring. Got it. Yeah, so it turns on the mirror at E1000. Okay. Yep. Which, well, no, okay, because yeah, we're not in the Fammy RAM right now. We're in the 7,000 range. So yeah, the 5,000 to whatever. The Fammy RAM is actually all of the BIOS with that one bit rewritten, the NMI bit. Actually, no, even the NMI bit won't even be rewritten. Would it? Actually, kind of would have to be. No. Yeah, because it's part of the ROM. Yeah. All right. Push a load store pull 7475. Backups. Got it. Let's put this in. Post ROM copy. Post ROM copy this guy here. Label adder, because it's only used here. 7F75. Var backup A and 7475 and then backup X. Load ones. Okay, that's the strobe. A B start and it branch equal. So that'd be. Wait. Hang on. What flag is that set and how does it set them again? What? Oh. Huh? There, okay, that's what I wanted. God damn it. Oh my god, and is absolutely everywhere. This shows the accumulator, so it's a 0 flag if the result in the accumulator is 0. Otherwise, resets the 0 flag. So if it's equal, branch equal. If it's not pressed, branch if not pressed. Oops. Am I reading that right? Compare 1, branch equal. Compare 2, branch equal. Load that, store it there. Go over there. Decrement branch not equal here. That's just a loop. There's no other branches in here, though. So it... And this is... Yeah, 4016. Yeah, okay. Load that sort there. Here. 1 stored there. Where else is that used? This is like a state of some sort. Setup clears it. Branch equal over to here. Prior to 1, so if it is 1. Let A. Redo the strobe. Load it and it branch not equal. What the fuck? Huh? This is some really bizarre controller input polling. I hate this so much. What the hell? Wait, did it just load? Compare it to 14. If it's equal, load 14 and store it. Why? Why? That doesn't make any fucking sense. That doesn't make any goddamn sense. Otherwise, load 94 and store it. What the fuck's the use of the table if you're not using those values? That's so dumb.
Would you care to join my following? No, sir.
Label. Adder 788A. Name. LED on. Uh, 773. 73 LED off. Dennis, how you doing? With a 652 and a Z80, you only need large enough tables to compute anything for trigonometry and logarithms. Really, really large tables. Now, comically large tables. Now, yeah. So the table that is reading here, right? It's a table of values that are written to a register, memory mapped I/O register, right? Basically, the high bit of this, not the high nibble, just the highest bit 7, turns on and off an LED, right? This little guy right here, that little LED. So the rest of this 4 is part of how the memory is mapped or whatever the hell, right? And you'll notice that the only difference between 14 and 94 is bit 7. So it's reading. Oh, it's actually reading it here, though. Oh, it's reading the actual value here. Okay. But other places, okay, load it, compare it to 14. All right, sure, it's equal, so we're going to turn it off. We're going to load 14 again and store it. Why not just store the fucking thing? Okay, well, if it's on, we're going to load the on value that we just loaded and store it. Bring with the bookmaker's problem. What about nasty tables needed for some math functions? Maybe? Maybe. Because I vaguely remember either watching or reading something about like massive tables of numbers for calculation shit. For like either, I don't know, fucking artillery trajectories or like fucking like material properties for like bridge building or some shit. I don't remember which. It might have been both. I don't know. But it's basically massive tables of numbers that you use in various equations to figure out either like the strength of something or the arc of a shot, I guess. I don't know. My memory is very fuzzy on that, though. Very fuzzy on that. I'm an expert with that? I have these books. Oh, you have those books. Oh, I see. All right. Yeah, grab a photo real quick. Is this like a state? Yeah, that's probably a state of some sort. This clears out both parts of it? Wait, what the fuck is this? And it was 7. You could load it. Yeah. Then OR it. Put that in X. This table's only... Wait, what? Huh? It only goes up to 8? Why? They all say secret and restricted info from the Yuma Proving Grounds test sites, but the data is 40 years old. Our ballistic data does not really change much for flying and rotating an object. Yeah. Yuma Proving Grounds. I don't know if I've heard of that one. The Yuma Proving Grounds. Oh, why PG? According to a comprehensive survey of Arizona's military installations, not Area 51. U.S. Army series of environmentally specific test centers. I see. La Paz County, Western Yuma County, in Western Yuma County, Southwest Arizona, excuse me. Approximately 30 miles north of the city of Yuma. I see. Interesting. What really changed? Well, see, that's the thing. The math doesn't really change for, calculating trajectories and arcs and all that. So once you figure it out, it's, you're good usually, typically. Which, if I if I am remembering correctly, the solvers for they were on like early like battleships for the firing equation, right? So to figure out like, okay, I want to hit that thing, I want to hit that side of the mountain, it's X distance away, right? What do I need to set my angles at for the gun thing or whatever, right? Those machines were like, I don't want to say hard-coded, but I mean, it, massive mechanical monstrosities to calculate all this stuff. I see one night right underneath one of these things, when the fire order came down and I yanked the lanyard, boom, it burned from my left ear. No! Yeah, those things are loud. Those things are loud. Not that I would know, because I haven't been around one, especially when firing, but yeah. Whole piece of artillery. Yeah. This day, the ringing is continuous. Whoa. Yay, tinnitus. I decided that they can launch 2 projectiles in 2 different paths and land one right after the other. Yep. Yeah. What am I even looking at here? All right, I don't really want to reverse the Animod code right now. Let me go back to why do I have these temp files here? Like, those shouldn't be there anymore. Did I mark those as precious or something? Like, what the hell happened? No, what the fuck? Oh, is it because they're like these guys? Yeah, I think so. Racing Mars, how you doing? This is interesting. Do a lot of Go, and I do some assembly for some architectures, but I've never combined the two. So the assembly is 6502 assembly, which is a little older, and the Go is a lot of the tools I've written to help me along the way. I'm not in Go right now. It's mostly just reversing and stepping through 6502. The multiple fire problem solved in the 50s And then the Geneva Convention made a barrage a war crime, rightly so. Matthew? Who's Matthew? What? Matthew? Time for me to get a Z80. Ah! You're Matthew! Hello! I see. Well, welcome. Where am I? I want to be in... No, I want to be in... Thank you for the follow. Appreciate that. I want to be in... Nope. Nope. I need to fix that fucking error. I need to find out where that comes from. This guy. Okay. QD ROM start. This guy here. Okay. Jumps to CPU. What the fuck? Wait a minute. Disable the IO. Okay. And then JSR over here. Ooh. Okay. Okay. So this is what kicks off all the copying, I think. 7C42. Maybe. The fuck? This is data. No, let's go up here. Let's get rid of that guy for now. This guy. My ranges. Range. Start 7C42, end it at 7C46. 7C46. That's not a 6, that's a 6. Type. You want to paste? Nope, want to make. Thank you. Yeah, no idea what that actually is. Might be data, I don't know. Real hardware quad. What? I know some of those words, huh? VMware cluster. 4 architecture VMware cluster on real hardware. What the hell? All right. 2.5 hours. I'm not watching that now, obviously, but I'll watch it later. Yeah. Beethoven's 5th Symphony. All right. So this. All right. So this is getting the inline data. 3 bytes of that. Don't have it. Param size 3. Okay. Yep. 2.5 hours. It'll take you days to repeat the steps. What is this? Okay. Yeah. Loop for. Huh? Oh, right. That's updating the return address. Yep. Okay. VAX Alpha Itanium and x86 hardware, all running on the Open VMS operating system in a VMS cluster. Fun times. Fun, sure. Step 1, get a VAX station. Okay, I failed step 1. Time and coffee? Yeah. No. Fun, like to assembly. If you say so. Why do I have that as 2 separate that's 1 double width. What the fuck? Size 2. It's a goddamn address. Oops. No. And so is this. This is a goddamn address as well. Why do I have 2 separate labels for them? I can spell size correctly. There we go. And same thing here. 2 separate goddamn addresses. Why do I have them as size 2? What do you... Oh. That's annoying. Okay. The hell is this doing now? Load up something. The first thing. $7C42. That's what this is. That's 7C42. Oh, data here. Okay, cool. Loads up that. Zeros, what the fuck? Store that into here. Of this. Jesus Christ, why the fuck? Oh my god, I hate it. This is one of the ones where it like daisy chains these fucking variables, doesn't it? Kind of? Maybe. Okay, Alpha Station on eBay. Under $1,000, not bad. That boy's chonky though, my god. Chonky. Right, I need to hit the bathroom again. I'll be back. I'm drinking too much. God damn it. Okay, I'm back. All right. Excuse me. So I think this is setting up copying large chunks of data around. Basically getting stuff set up for running the ROM. 7C42. What the? Wait, this is 5084 D828. Is that? That might be source destination. D828. This is the post copy. Let's have a look at the pre-copy for this guy here. D828. Is that in here somewhere? It is not. Why? Space D8. No, because it starts at DC. God damn it. D8's the other one. I'm just going to buy it now. Also, memory slots. Also, not DDR5E, CDR4, or DDR3, or. Ripping here from the SCSI? Oh my god, that's. Looks like it's seen better days. That is a lot of open RAM slots. My god. Shit's built different, you know? What in the So there's RAM slots up here, sure. What the hell are these? These slots. Is that more RAM? Is that ROM for something? Cache. Okay. I see more cards up here. Per CPU, local cache, yeah. So one CPU, another CPU. This is missing. Is that CPU? Missing a heatsink. Philippines. All right. Digital. Big old fucking heatsink there. Something is amiss. Yeah, what's that? Windows? Windows? The fuck? All right, images of the thing booting. Windows sound hardware. Ah. I see. All right. The audio board, yeah. I figured when you said sound hardware. All right. So this guy here. Transfer S to X. Stack to X increment. Let me actually run this one in the emulator here. Wait, is that what's up now? It is what's up now. Awesome. So this is at 7 something. Shit. That's not the address at all that I want to be at. Oh, because we haven't hit the we haven't hit that yet. Okay, got it. Post copy entry. There it is. Okay. All right. So this is gonna go, and it's not going to get the slow. Yep, no slow. Disable it there, and then this 73CB. Is that where I am with this? Yes, okay. Yank it and toss it. HB Kayak? The fuck is that? Okay, so I'm gonna jump into this. So the return address right now is 7C3D. 3D7C, that's going into the data. The data start. So let's actually rename that to params. So that's gonna be size 3. whatever. Prime pointer. Thank you for the good stuff. Appreciate that.
He's the most powerful hacker of all time.
Racing Mars, welcome. Pram pointer, I guess.
Hacker man.
Like
He's
that.
the most powerful hacker of all time.
Thank you for the other gifts. I appreciate that. Thank you, thank you. Okay, so Pram pointer, yeah. All right, geeks. Right, so let's get in the point of that. Let's file workspace, import labels. Post copy. Select. How dare? What? Oh, because the post. Well, no. Hang. Huh? See, why the fuck? That's in the right spot. 59, okay. Select. Thank you. Cool. For whatever reason. What? Yeah, work RAM. Why? Why? Edit label. The address is wrong? What the fuck? How? Because that is pointing at the code, which I do not want to do. I want this guy. 7C6B, this one. 2C6B. How the shit has the... What? Oh, it's annoying as hell. 2C6B. Why the fuck? Huh? What? Why is that fucking broken now? NES work RAM. Why doesn't it do subtraction correctly? Let me XY, how you doing? Deprogramming something like that? Kind of. I am reverse engineering a really weird pirate device, basically, for the Famicom. Barely above the wire. Yeah, right? Yeah, very barely above the wire. So this is the setup. So we've got the Famicom right here. Got the Famicom disk system at the bottom. The Famicom disk system RAM adapter. A Famicom cartridge or game. And then this right here is what I'm reverse engineering. The Souseiki Fammy. Yeah, floppy. Yeah. Yeah, this right here is a weird little device that has two cartridge ports on it. One for the RAM adapter, another one for the cartridge. And it's got a little bit of RAM and a bunch of 7400 series logic. In fact, internals cleaned. This is one side, and it's the other side. So, yeah, a little bit of RAM right here. And then everything else is 7400 series logic. Everything else. And basically, yeah, ORs, NORs, XORs. There's some shift registers in here, I think. There's one or two of one of these is a shift register, I think. There's like a demuxer in there somewhere, or a demultiplexer. I don't know. Something like that. I don't completely understand it. The hardware of it anyway. But basically, what this device allows you to do, right, is two separate things. Three, but we don't have that disk. So I'm ignoring that one right now. Can I post that image somewhere? Sure. The schematic. So about the schematic. Hang on. One of those actually exists. Because the main reason for getting pictures of it is to actually, it pops up, trace everything out. So this here is mainly the traces of the hidden shit, right? So there's a bunch of stuff that's under these chips. This one's the most egregious. Where there's a bunch of traces under these chips, right? So it's a dual layer board, and it's a mess. Whoa, yeah, it's a mess. Give me a second though. Over here, no, I want the profile. Or yeah, so we can go to my stars, and Ederfaus, the absolute madman, has taken this and the images and drawn up a schematic. So a schematic exists. The repo link, by the way, is over here. But yeah, so this is the schematic for it. Ederfaus is the one that handled all this. I would love to be able to get a board layout for this, so I could order more boards for these things. So I'm not keeping this hardware. This hardware is going to go to someone else, probably next month or so, towards the end of next month. That said, I would still love to have the thing. And because it's all 7400 series logic and RAM chip, essentially, a few capacitors here and there, and a few resistors here and there, and some switches and whatnot. There's no CPU on this thing. There's no crystal. There's no FPGA or anything like that. It's all 7400 series logic. So in theory, it shouldn't be too hard to recreate. The hardest part would be the metal casing, I think, for me. But yeah, I'm confident enough in my soldering skills that I'd be able to, solder one of these together. And that'd be a fun thing on stream, right? That'd be a fun thing to do. But yeah, basically this thing just handles remapping basically which slot it's reading from, and overlaying this RAM chip on top of the disk system, either the disk system ROM or BIOS, or the cartridge ROM itself for the slowdown stuff. Excuse me. But yeah, discard changes. So the schematic does exist. We just need a board layout now for that. Why are these fucking broken though? Like, that shouldn't be broken like that. Let's see, where's the make file? Make file's there. Yeah, RAM start 5,000. So why the hell are these not changed? 7C6B. To D. Yeah, okay, that's... These guys up... Oh, it's a range. I bet you if I took out the size... God damn it. Okay. I need to fix that. Give me a second. Oh, it isn't here. Tmux. Vim. Config. This is why right here. To this one? There we go. That's better. Okay. That's better. So now I can go back over here. File, workspace, import, select. There we go. They're fixed now. Okay. Okay. We're good. All right. Let me follow along here. Quit out of that. And then quit up there. Okay. Somewhere I have a full schematic of early Commodore PET. Oh. I was luckily over at archive.org as the Commodore people printed the whole schematic in the user manual. It was better days when that was done just because. Yeah, right? Much better days. Okay, so we are at the branch right there. 11, yep. Where's the pointer? Why did I increment that pointer? Let's add a watch to this, though. Add to watch, thank you. But that is a pointer, not a byte. Oh, it increments it because the return address is 1 byte before where it's actually destined for. So it... Okay, yeah, okay, yeah. Yep. All right, and now it's going to increment the return address by 3. So 7C40, which is going to be that 60 right there. Yep. All right. 7C3E. Wait, where was that? 7C3E. Oh, that's the inline. Oh God, that's this right here. That's okay. That's why I didn't see it writing it to a variable anywhere. The variable is the fucking. Oh God. All right, sure, fine. Load. Store that there. That's a counter then. All right. So only one thing to do, and that's, yeah. So this here, that's a loop counter. Oops. Let's get rid of that. Let's get rid of that. The vars. Label, adder, what is this? 7FDE name, var, loop, counter. Size That's a one size. I don't need to do any of that. Oops. Make. Loop counter. Did I do that right? 3E? No, I did not. Did I? I'm looking at something else. Load A73CE 78. Oh, that's this. That's why it doesn't have the. That's fine. Okay. Yeah. Actually, 73CE. No, I'll just leave that as is. It's fine. What is this ID? You have labels. This is a macro ASM for. So this is Messen. So this is the an emulator. Emulates the NES, the Super Nintendo, Game Boy. Game Boy Advance, PC Engine, Sega Master System, the Wonder Swan, and whatever the hell other systems is. I don't know what other systems is. Yeah, it's an emulator with some very nice development tools. Yeah. Yep. I had to patch this a little bit just to get this stuff working, because normally the disk system only has enough RAM for address 6000 up to DFFF, I think. So the 5000 range, the 5 to 5 FFF, doesn't typically exist as RAM on the disk system. So I had to go into the emulator and modify that to give it some more RAM. Always. And I also had to remove some hard-coded labels as well, because number one, they're outdated, and number two, I didn't like them. I need to figure out a way to patch in being able to load those dynamically from a file. Yeah, unlocked. I downloaded more RAM. Yeah. Yes, this is my patched version of it. I have seen the monster. Yes. Yes. I kind of want one, but do they make those anymore? Was that like a limited run, or is it a DIY project? I don't remember. But yeah, full 6502. That runs ungodly slow. Don't think it was ever sold. Yeah, it was like a kit or like a set of schematics and layouts and all that kind of shit they could make yourself. I don't know. Dispatching schematic for an AM5 motherboard. You just have the CPU that needs 1,718 connectors by itself. Mm-hmm. All right. Anyway, so right there, load X2, 73CE. That's gonna be 73CE. So that's these two guys. So we're getting the parameters now. 742. Where'd that put it? 7C8B. Put it in the next load. Okay. Now, load X. So now, doing like 3 steps of dereferencing. That's so painful. Oh god. All right, so now it actually loads the actual data that we want to look at. 7C42, which is, yep, that's that actual data now. God. 1, 2, 5? Load it. Store it. Increment. Branch out equal. Wait, increment? Why the fuck? Increment X. Why? Why? Why are you doing a load absolute instead of a load absolute at X and just use X so you don't have to fucking increment the goddamn pointer in code every goddamn time? Why? You're already incrementing X. Just use X. Ah! I hate that so much. F DF. All right, let's look here. No, I don't want to edit logo. I want to actually look at that in code. View memory. And then, what is that? Why is it load X 0? That doesn't seem right. Oops. Oh, God. Oh. So we're at load X load Y. 05A0? Okay, so that's a load Y. What? 2 loops. What? Oh, right. Yeah. Oops. Labeled adder 7C8B. Name. Inner. Inner and then the outer loop. So the inner loop. Wait. It's at the bottom there. Okay, yeah. Yep. Inner loop. Right. So this is for copying each row of what is this? 5? 1, 2, 3, 4, 5. Each row of 5. Right. Copies each row of 5. Does a thing, and then goes to the next. Okay. Class control patterns with self-adjusting precision and using MPFR, just beer and chess for the coin. Intel 4004 is all you'll ever need. It's a netgram with 64 kilohertz refresh. Everything else is just gamer RGB flashing lights. All right, so all of this code up here is prep. Whoa, what is prep for the input to this routine right here? This routine actually does a copy. Okay, so that guy adder 7CBC name ROM copy. ROM copy. We'll call it copy. B, D, not C. There it is, the ROM copy. Right. FE1. 1, 2, and hang on. Where does it put this again? 7FDF. DF. All right. Label adder 7FDF name param copy size 5. There we go. Is the first one ever used? No, it is. Okay. Oh, because that's like type or whatever, right? Right. That's, hang on. There's some notes on that, isn't there? Is it up here or the hell? This here. This is the transfer routine. This is the 5 byte. Yeah, free transfer in the struct. Transfer mode, register value, source page, 50, page count, hex 28, destination page. That's what that is.
That would mean that we have, with this brain,
Call it that. Why not?
a septillion times smaller than the tiny planet it
Yeah.
lives on. Discover something true.
Right. So this does a lot of copying. So it's going to copy from 50 to D8. What's in 50? What's at 50 right now? It might actually be well, that'd have to be actual ROM code from the cartridge, I think. Probably. Let's workspace import. Yes. One more. Okay, we're good. Load up that. Compare to 0. Branch not equal somewhere else.
If they do, if one day physics finds a use for
Is this
that's great.
PPU transfer? Okay. So yeah, 39. No, that's a loop. Clear flag. No, set flag. JS already here, which just does setting memory. RTSs clears the flag. Where is this from? Ah. Branch not equal to. That's where that's from. Okay. Yes, so that's CPU exfer. That's what that is. Because there's a PPU version of that, which is here. Where is that? Somewhere in here. I don't know. But that might just be a lot of dead code, because I'm not sure that that's ever actually used, honestly. At least not in these ROMs. So like I mentioned before, there's one more disk that we don't have dumped. Yeah, one more. And my guess is a bunch of the stuff is copy-pasted across all the disks. So this dead code could be something that's used in that other disk. We just don't know, right? CPX4, yep. Next, and then this guy. First, I to go over here. So not equal goes to unit wait, param transfer set flag. Load data. This is reading PPU. $7D74 name. Equal X. Branch not equal. How much does that read? I don't know if X is actually cleared anywhere. It's cleared right there. Okay. So this and store must written to 7D88 address before calling. This here label adder 7D43 name SF read PPU PPU read X for. CPU read PPU read X for right there. Okay. This one is gonna be PPU write X for, I think. Right? Because this guy is gonna be writing to the PPU. Yes. And for this one, source data address must be written to 7D3B. And PPU address must be written to 7D to E before calling. E2D. This guy, yoink, paste, that's going to be 7CFB, 7CFB, right exfer. Okay, that's this guy here, then right PPU. Okay, where's the read one again? Read PPU here. And PPU address must be written to 7D75 before calling. Oops. Okay. Don't know what the hell this is. 79B. I don't know. Come back to that. Increment, decrement, branch not equal here. That's a loop. We're just gonna leave that as is. This guy. I beg your pardon? What? Store that. Branch transfer plus 3. Zero, 1, 2, 3 page count. Header 7FD0 name our page count. No size. Page count. Store that here. Okay. Should probably make a better name for that, but whatever. Just the high PPU at not the address, but the PPU high byte. PPU address high byte. Commander, how you doing? He's streaking. Welcome, welcome. How you been? Oops. Okay. So this is the transfer routine. SF like do transfer or some shit. Label adder 7C47 name SF transfer or exfer. What do you mean already defined? How dare you? There we go. Param size 3. Comment. Transfer data. Expects 3 inline parameters. Um, extra count. 2 inline parameters. 3 bytes. Extra count. Table struct pointer. Three bytes. I can learn to trust the magic, especially with a zero. What? I can learn to trust the magic. Yeah, well, I'm not working with anything modern here, so. I wish I could like enter a new line after this right here. Is that a thing I can? Hang on, let me look at the parameters again for this. Excuse me. Label break. No, I want to come on new line after jump. New line after RTS. Let's set both of those to true though. See what happens. Didn't change anything. Okay, cool. I'm making some way to change those, but whatever. What do you say? Retro assemblies of the Gunpla of programming? Maybe? I don't know. I'm not very familiar with the Gunpla scene. I know of it. It's just I'm not very familiar with it. Okay, this affects for here. I don't know why. Like, why do you need the extra? You don't need this here. Like, why? Wasted bytes, wasted cycles. Like this, honestly, should just be like right there, like that. You know? That's what it should do there. But no, it's gotta do it dumb. C3B. Do extra, yeah. All right, sets the mirroring and then goes to the CV vector set. Very manual thing. Yeah. All right, yeah. So so what did the okay. Okay, so the D8 to DBFF, or hang on, actually, what is? All right, so D8 plus 28 gets us to the end of the address space? Wait a minute. So D800 plus 2800. Okay. Goes all the way up to 78. God, it's, and right, 78 was what again? Wasn't that? Okay, yeah, 78 is the. Oh God, this Jesus, the way it fucks around with this. Oh my God. So some of the RAM, some of the ROM, is directly loaded to where it needs to be. Right. So the ROM from 8000, hex 8000, up to here, D7FF, is loaded by the disk system into the proper address space for it, right? It's loaded at the right spot. But then, because we have to copy some shit around for the slow ROM and or either the slow ROM or what's it? The high bank, the E1000 range, right? Got to overwrite that. We have to shuffle some shit around into the right memory places before launching the game. So some things are loaded correctly in their final destination, and other things we have to shuffle a lot. And then there's some stuff outside of the 8000 up range for the slow ROM bullshit. God, that's confusing as all hell. God. So 8,000 minus 5,800 equals 28. Okay, so file 4. File 2. File 2 bin. Now this one link paste. And let's also grab file 3. Two and 3. All right. File 2, 8. Good. 58. Okay. Yoink. Paste. This one is going to be file 2, start address. 28, but input offset of 2800. DK3 file 2 5800. Forget. Oi. Thank you. Yoink. Paste. Start address 58. Oops. 58. That's not input offset. That's input size. Input size. What? 5. Global directory. Input size. Input fucking size. What? And input offset is correct. What are you on about? Huh? No. What? Post-ROM copy. Input size. Go to hell. Offs. God damn it. It's so dumb. All right. Hex 8000. No. Huh? No. I probably need a proper disassembly of this as well. Honestly, the actual ROM itself, rather. All right, and this guy, going to 5800. Break? Go to hell. What? No, that is not 58. That is D8. Right? D8 plus 28 equals, yes. Okay. And that might be right in the middle of a goddamn instruction. Oh my god. It fucking is. Ah! Oh my god. Yeah, okay, that's like an LDA, isn't it? A9. What instruction is that? Get out of there. Load A immediate. The copy cut instruction in half. Oh boy. Okay. All right. Okay. So, what I really want to do then with this stuff. What do I make file? DASM dk3 rom.asm. Not these two. That's going to need file 2 and file... Well, no, file 2. Okay. But I need to chop that up. Yeah, decimal, don't I? Okay, so if I do... Oh, BO. Come on, no. BO. BO, thank you. Jesus. So, if I do... let's do DASM DK3 ROM ASM. That needs... that. As well as this. Like that. First thing that's going to do is going to head the first thing. N, or head N, 10240. Actually, hang on. No, I need to tail it. Tail that. And put that into bins dk3 rom.bin. Then head and 1020 to 40 of that. And put that at the end of this guy. Then DA65 input this, just the config, output that. Right? Maybe. So I'm going to tail end of it. The tail this bit. No, hang on. Yes, the tail comes first because that's 8,000. And then this guy, the head of it, is the end of it. Okay. 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 Make. Okay. DK3 ROM kafug. Yoink. Paste. ROM start address 8. Make. A break in the that doesn't seem right. That is, did I do this wrong? Maybe. I might have done this wrong. Did I get them backwards? Buzstronic, how you doing? Welcome. I might have gotten them backwards. Okay. 8,000 is offset. $2,800. Oh, no, I need the size of that file minus 2,800. I'm done for now. It needs polish, but LSL bins DK3 file 2 bin. Oh, that's not even all of it either. 16. That's too small. That's too small. What the fuck? LP, no, LP, what? FDS list, ROMs, DK, SF, DK3, FDS. Okay. File 2. The end of file 2. I did do it wrong. All right, end of file 2. So this, 98 minus 80, 18. No. 98, no, bastard. 9800 minus 8,000 equals that. 6144. Okay, the last 6,000 bytes of file 2. 144. And then I also need DK3 file 3.bin. That's just going to be all of it, actually. Cat that. And then now I do the head. Of 28, no, come on. 2800. 10240. That doesn't seem right. 10240? No. 9800 minus 8. God damn it. 6144. Okay, so this guy's the middle of it, right? The last half of file 2 is the start of the ROM. The first half of file 2 is the end of the ROM, and file 3 is the middle of the ROM. Oh, I hate that so much. That's still wrong. Why is that wrong? Okay, so DC to DF. That is all the Souseiki Fammy stuff. DFFF. File 4. That's all. Okay, all file 4 is that. File 2. Starting at 8,000. CLD. Okay. I don't know why these ADO2. I don't know why those. Oh, because it's like referenced somewhere. No, why the hell? ADO2. AD is like a. Wasn't that like the load instruction or something? Yeah, AD is a load. Load absolute. So that fucks up that. FBO2. At any rate, CLD is what we need for the beginning. Actually, let's go. 008D. DK3 ROM bin. No. Why is that wrong? That should be 00. That should be D something. That should be this guy. D8. Why is it not D8? Do I misunderstand how tail and head work? One 6 3 8 4 divided by 2. 1892. Okay, so I have these numbers wrong because half of that size is 8192, which is not 6411. No, I can't. 9800 minus 5800. 4,000. 384. Okay. Minus 2800. 1800. That should be the tail. Tail should be 1800. Six, no, 6144 bins dk3 file 2.bin. No. I need to do God fucking damn it. This number's still wrong somewhere though, by the way. D8. 7A. Okay, that's actually correct now. Okay. Okay. I don't think the head's correct, though. So if I... Okay, so this minus that should be what I need to head it with. Right? Hex, no, decimal. 16384 minus 6144. That is what I need to head it with. 10240. I think. Because that plus 6144 is the full size of the file. Maybe. Make, damn it. Nine 7FF. Okay, so we're still missing a bunch. This is the wrong fucking file. Here. Okay, there we go. That's better. Okay. All right. God, this is so jank. All right. And do I have... Okay, I want just the DK3 ROM. This guy here, the DK3 PRG. This is a straight dump of the cartridge itself, not from the dump. So if I copy dk3.prg, copy that into ROMs. The dk3.asm. That doesn't need a bin anywhere. That just needs the config. You want to call that, paste it there, and no. It doesn't need that though. Doesn't DK3, doesn't DK3 bin. What are the ones looking for the bins? Why is it looking for a bin? Because that's what I put in the fucking... God damn it. Okay. DASM. Yeah. DK3. Yeah. Ew! Why? Fuck you. They're the same? What are you talking about? Whoa, huh? This one's longer. Why? Because the PRG mirrors because the DK3 ROM is an NROM, a 128 NROM. It's half the cartridge space. Half of it. Beautiful. Okay. Oh my god. Oh, that took far too long to figure out. That took far too fucking long to figure out. Oh my god. Oh. All right. So, because the Souseiki family has stuff from D8000 to DFFF, the original ROM data has to go somewhere else, has to be loaded somewhere else, and then moved, copied, whatever, moved into there during the bootstrap. I hate that so much. I get it. I understand it now. I fucking hate it. Oh, God. Oh, Jesus. Look at how much shit I changed. Oh, man. So these two, I don't think I want anymore. What's different here? I gotta. I'll do that later. That's better. Add the make file, add the DK3 file 4 startup kafuga, add SF ROM QD file 1 pre-copy. What the hell's different than this one actually? Sure. File 1 pre-copy. Add that. Add dk3.kafuga, dk3 rom.kafuga. The hell's the ROM QD one again? Right. That that's actually used in ROM QD.kafuga. Right. ROM QD kafuga. And then git add sf slow ROM QD post ROM copy. Ugh. All right. A few more stuff. Yeah, okay. Confirmed layout of the ROM QD files. Confirmed the slow ROM setup for ROM QD disks. Yeah. Okay. What a freaking headache. Oh my god. What a goddamn headache. Shinkun, I don't. Linux doesn't have a stable, unchanging ABI, right? I mean, not as strictly as Microsoft, maybe. Well, okay, so yes and no, kind of. So the kernel has a fairly stable ABI, right? Linus is very adamant on not breaking anything, not breaking user space, essentially, right? Which means that any changes to ABI must be well justified, right? GNU doesn't hold the same philosophy and breaks ABI all the goddamn time. So glib, I think it's glib, right? The GNU C libraries, if you the standard lib, if you're using that, that breaks all the goddamn time. Torvalds is not exactly happy about that, but his projects or whatever. But if you pick a more stable CLib, standard library, be more unchanging, I guess, right? But yeah, it's a bit of a mixed bag. Bit of a mixed bag. All right. I'm gonna hit the bathroom again. I don't know what it is with today. But I'll be right back, and then we'll figure out next steps. I'll be back. All right. Back for a quick nap. Welcome back. The Linux kernel ABI maintains a backwards compatibility for at least a decade. Yep. Sometimes they'll have executables built back in the bad old days with broken tools and whatnot, and still test them every so often to make sure they still work. Userland, however, is a dumpster fire. Yeah, that's the GNU C library stuff. That's the dumpster fire. Yeah. Meanwhile, Windows, did it run on 95? Yes, probably still runs. Yeah. And okay, for security reasons, some tricks get locked out by the kernel, but are still re-enableable. Yeah. Little thing like the ability to mmap a page to address 0. Or some characters in a PWA's input buffer from the client side. Well, yes, but actually no. It's one of those. For all that shit you can give Microsoft, at least you have to admit they're great with backwards compatibility. To an extent. I've used or plan to use those two tricks. How dare you? God damn it. Of course. Why else would you mention those specific things? Of course. Of course you tried some bullshit with them. Of course. But yeah, Windows has compatibility as far as like ABI stuff, I guess. But when it comes to what's it? 16-bit stuff, it's killed that 16-bit compatibility. You can still do 32-bit stuff, but not 16, right? All right. So I think the only one I haven't really... Okay, so I haven't stepped through this guy to see how it actually works. But I did need to do that. But the only one I haven't started to disassemble yet is the BB RAM. I was even born back then. I was. Get that 16-bit. How is that now? I don't know. 90s? Early 90s? 80s maybe? I don't know. 80s, 90s, somewhere on there. All right. TASM SF. BB RAM. BB RAM. So I'm not sure if this one does a copy. It might, but it might not. So we're just gonna do this first. Bins SF. Maybe I need to know what's in there actually. ROMs, SF BB RAM. There's only one file. Okay. File 1. Q3. Ooh, no, that doesn't actually work. Whatever, it's fine. I'd have to rename these. I'm not doing that right now. Bins, SF. What the fuck do I call it now? BB RAM file 1 dot bin ROMs SF BB RAM dot FDS. Yes. Gonna take this, paste file number 1. SF BB RAM dot configure. Yoink, paste, start at D1000, SF BB RAM file 1 dot bin. BB RAM. Okay. Make. That actually does have the labels on it. BB RAM. Okay. All right. So, whoa. see if this does any copying. It's an RTI. Okay. RTI, and the reset here. This might not do any copying, actually. Amazing. Amazing. Okay. Label. Adder. DE00. Name. Be reset. DFC0 BB NMI. And then this one is IRQ or empty something something. DFF0 empty vector. That works. Okay. How dare I? How dare all of ours require mapping into zero page? How dare less require hidden return after an external command completes with no way to disable it? You can't reference null. Maps memory to it. Yeah. If it weren't for that thing with less, I'd have even more glorious pile of hacks masquerading as reverse engineering disassembler. As reverse engineering disassembler by now. Windows 3.1 on a 286 and 1 meg of memory. 640K conventional. Windows 1.0 just needed an 8088 and 256K. Have you seen Windows 1? Looks like ass. All right, range. Start DFF1 and DFF5. Type byte table. Okay. This is probably all trash. NMI. Why does the NMI have this bullshit? Why does the NMI have a break, actually? What the fuck? Wait, what the hell is 8D? Store absolute. Huh? Range. Start. DFC0 and DFD9 type code. Oh, that's why it's doing that bullshit. Okay. I don't know why this is still broken. 8E. Store X absolute. It's literally, what the fuck? What? Oh, because the RTI. What the fuck? Because the RTI? Oh my god. FE0. I hate that. And mainly because this probably isn't even part of the fucking code, honestly. Yeah, I don't even think that's part of the code. All right. Maybe reset. DE 1000. Okay. Store here. It's a counter of sorts. Range. Start. DE00 and DE21 for now. DE21 type code. Of course it has these. Oh my god. Why does it copy itself out like this? Because it has to. Because it has to. Because it's going to be loading up the fucking cartridge. Of course it has to. Duh. Edifast, how you doing? Memory mapping is 4K pages. We can play games with low RAM mirroring and use mmap for bank switching on the NES emulator. And the CPU core gets faster memory access. Oh my god. Combination of a custom input filter and a keymap on less is a powerful combination. The ability to use an external program without an extra force key press ruins the entire thing. Yeah, I can see that. All right, so this is going to be... all right, move SF BB RAM pre-copy. 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 All right. And where the hell is it copy this shit to? Yeah, I know. Reset. 5100. Starts at 5100. Okay. Post copy. D8 plus 7. Hex D8 plus 7. DF. That copies absolutely all of it. Copies everything down there. All right, well. Can we do the extra stuff and family stuff? Yeah, all right. But all right, not too bad. Yeah, I've been figuring out what these discs do, pre and post copy. Yeah. Once you've been borrowing documentation and product QA for software, I hate doing it, but it's really nice to have. Okay, so everything up to here is just data for now in the pre-copy. Range, start, D800, end, DDFF, type, byte, table, make. Yeah, whoa, 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 no, not, huh? Wait a minute. Reset. Copies D8. Just D8? Oh my god, fuck you. Why? What the hell is the rest of this shit then? Delay? Oh no. Is this just copy pasted bullshit that is ignored? Cause here this looks like the fucking transfer routine. That's what this shit is. How dare? what's at the beginning here? Yeah, this is. Oh my god, this is one of the other fucking ROMs. What? God damn it. Did I load this right? Hang on. Yeah, D1000. There's so much crap in this. So much crap. Because this isn't used anywhere. Right? No, that is used. Okay, that is used. So that's the screen setup right there. Label, editor, DE24, name, BB, setup screen, or init screen. Yeah. For some reason, I'm just making one disk, except for the reset pointer being different depending on which disk it's supposed to be. That'd be cancer, but no. So they are actually different, kind of. But it's like they're using the same, like, library or something, or they're copy pasting code like fucking mad, like absolute mad. Which leads me to believe that I'd be able to put all 5 of these discs, so there's 4 physical discs, but 5 sides, onto a single side of a single disc. Right? I'm confident that I'd be able to figure that out. Right? And, like, the only difference would be, like, when you load up the disc, it just asks you which one you want to do. Using one project and starting for another, thus copying code is unreasonable? Yeah. Yeah, what gets me, though, is that, like, apparently, we haven't done the post-copy stuff yet, but so far, this stuff isn't used. And it jumps to a reset vector that this disk wouldn't use, I think. Maybe? Well, actually, I don't know. Because you will need to insert a new disk, actually. But that doesn't make any sense. No, the way that does... we'll get there. We'll get there. Yeah. Because user space API is so unstable, is it much more costly in time for you or other devs to maintain package compatibility? It depends on, like, what your package does, honestly, and the things it touches. You know, a lot of times, like, if a straight recompile works, then just a straight recompile will work. You don't have to worry about it. Yeah, what your package does and how it does it. Yeah, it depends on so many variables. No. So many variables. For Loopsy package, probably for everything that just uses Loopsy, not so much. Yeah, this Flatpak is a thing for a reason. Yeah. Okay, so reset copies from D8 to 5100. So we're gonna D8 to DFF byte table. I already did that, didn't I? That is stuff that's copied. Then range start D1000 to here and D7FE that's nope. Garbo probably. None of it's referenced here. It's FF, okay. Off by one. Garbo, probably. And then this is the copied code. Gritty Garbo, sure. That's all the stuff that's copied. And it copies itself, too, for whatever the hell reason. Like, it copies this, which... Why? Then there's this crap. I'm not sure entirely what all this is. Range, start DE69 and DFBF. Yeah, okay. And then we're going to do another byte table for the little bit here. DFE3. E3 to DFEF. There we go. Okay. So this is probably other code that's... This is probably code that's used post-copy or some bullshit. All right. This guy. Sure. That guy's a loop. Branch out, goes another loop. Inner outer loop. Okay. Label adder. DE05. Name. Loop. Outer. DO7. Why? Why did it let me use the same name for these? Oh, okay. This guy's loop counter. Our counter. DDFF. Counter. and those. Okay. Very basic shit. Oh, this is okay. This is the data that's referenced up here. These guys. That's what that is. That's what all this is. That's VRAM data basically, and some padding. Yeah. D69. Yeah. D69, D7D is in there too. Yeah. Okay. Okay. SF BB RAM post copy. Paste that. Start address is going to be 5.1. But we're actually going to jump into the file by 800. Ignoring the rest of the stuff. No. Make file. Post copy. And okay, I do have the post copy there. Make DASM. Post copy. Stop it. Yeah, all right. Stop it. What? No. All right, so this guy, label. Adder 5100. Name. BB post copy entry. JSR over to here. Drive status stuff. Load store, load store. Label adder 518E. Name L518E. Size 2. That's going to be some data. Range. Start 518E and 51A7. $190. Yeah, that's the start of that. 51990. That actually, hang on. Range nope. 90. $518E and 518F. Type adder table. That's one of those. Okay. Don't need that. There's no 5392. Okay. that's there. I don't like that. Don't like that at all. Five three nine one 5392. Okay. Label adder 5391. Name CV 5391. Size 2. Yeah. That's a parameter into something. These guys here. 8485. Five three eight four. 5. Yep, okay. And this guy is, yep, label adder 5386, name BB V RAM struct right. This guy, whoa, there's a lot of theirs. Okay. Label adder 53, no, 535C. BB FDS reset IO. Okay. Oh, what? This guy. Construct right. This is probably like draw screen or some shit. Or no, this is gonna be like. Hang on, let me do this. I'm gonna go over here, file, open. BB RAM, select debugger, add breakpoint to 5100. Execution on that, go. Okay. All right. What does it do? There. That's gonna be that eject disk, I think, actually. Game, reload ROM. Go. Yes, okay, so that's the right, excuse me, eject disk. Label, adder, 516B, name, BB, right? Screen eject disk. Oh, well, that's not really, that's just writing it, actually. Draw. Okay. So F10 over that. No, that is the full screen. That's not just drawing. Okay. Settings. Game eject. What the fuck? What? God damn it. Game. Reload. Boop. Okay. And this one is going to be like set, I think. This guy here. This is data. Range. Start 51BA and 51BB. And then this is 51BC down to D3. Yep. Okay. So this one. What up? This guy. So that's another. God damn it. Another one of these. Paste. 51F7. 7 to 8. And then F9 to EF10, 5 to 10. Maybe. Yeah. Right, so this is going to be another screen for set data discard. Insert. Location. And then I want to, okay, edit that. 3 F. Yeah. Okay. So that's going to be screen set disk at 51D4. Load 3, JSR over here. What's that doing? Load 3, JSR over to here. VRM struct right. How dare you? Yoink. Five, 3, B3. 3B4. 3B5 to five through CC. FF00. FF00? What the fuck? Maybe not. Store that there. Load that. We'll store it. VRM struct rate. That's... Whoa. This guy. Okay. Where are you? Right there. Okay. 5, 3, 4. So I don't know what that is then. Or that, because those are wrong. Range. Start. 539D. And where? B3, yeah. 53B3. 4. Oh, that's gonna be like color or some shit. Yeah, for whatever screen this is. 2, 1. Pen file. Maybe? What the fuck? All right, so we're currently looking like that. Gonna jump over that. Now save, wait. Got it. Now save. Okay. 5367, 5367, BB, screen, save, wait. Wrong. 5367. Not 5. To FDS a pen file. What is this again? This PF object. What the fuck? Hang on, let me look that up. DISPF. Disable rendering for both sprites and background. Got it. Okay, so that turns the screen off. Reset IO. What is this? Wait for ready. Load the control mirror. Control mirror. Not that screen. Damn it. That screen. Okay. Come on. Thank you. Control. And it ends it with 2B. 2B? What the fuck? 2B. Okay. Turns off the transfer mode, makes that right. Vertical arrangement, because whatever. No CRC, always set to 1. Okay, so it turns on write mode, essentially. Stops the motor. Transfer reset. And turns on write. Okay. Disk format routine has to manually write the disk info block in the file amount block. Right. Now. Yeah, I'm just looking at like what this control is. But yeah. Write data, delay, write block type. Excuse me. Type FDS stir. Sure. Transfer byte, decrement Y. Y is the sure. Is that like that static string that's in all the block header things. Nintendo, whatever the hell. Is it copying it from the location that it compares it to? Is that what it's doing? But yeah, so basically this is yeah, format, like, yeah, format then? Yeah. Okay. Five, 2, 1, 1. Format disk, why not? Gotta write the damn thing first. Save weight. Append file. Sure. Save weight. Oh god, is this another transfer routine? There's a transfer routine. Fantastic. Yep. What the fuck is this? That's all data. Range 5250. Oh, start at 5250. End .526C or C6. Much the same with the file. Oh yeah. Yeah. Yeah, I noticed earlier. I'm not sure if you were around or lurking or whatever, but earlier, this file, the BB RAM fucker, it has so much data that apparently is just unused. So it starts at D1000, but only copies from D800. It doesn't copy D000 to Fammy RAM and jump to it. No, it copies from D800 and then jumps to that. So I'm not even sure if, like, hex 800 bytes are used. They're just there. That's SRAM writing program, which gets saved with the SRAM. Oh. Oh, is it? Okay. 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 That makes more sense. That makes more sense. Yeah. Okay. So right back to the thing. Got it. Got it. Got it. Got it. Got it. What? That's it right there. Okay, yeah. That's that routine right there, actually. Not what I was looking for right now, but... Huh? Oh, we're not in the address space. 5100. That's our address space. What a mess. Oh, huh? What do you mean data? I don't know the data. What the fuck? No. Make. Oh my god. Nope. To A3 to 5 to C6. There we go. I hate these old things, by the way. I hate them so much. Only called in one fucking place. So why not just do this up here? Like, what the hell? I bet you because, like, this part, like, is actually rewritten or something, right? Like, this is one of the variable bits of it. Some of the non-library crap. I bet you. This is the 4-byte version. 52A3. Oh, that's the stuff here. That's this. Unit 4. Yeah, okay. Copying 60 to 58. And then 58 to 80. Five two nine C. Name maybe. Actually, I'm copy. Maybe if I had the right address, that'd be nice. 9C, not 6. There we go. All right. We said, yeah. Oh, that's the append file. Okay, yep. I'm not entirely sure what that does. This guy. EMPF. What the fuck is that? Enable background. Okay. Screen eject. Oh, and go to the top. Okay. 5103. Name. Menu loop. Menu loop. Okay, and what was this one up there? construct, right? PC. Which one was this? 5188. Execute. Okay. Go. Okay. Branch not equal. Branch not equal? Oh, is this like for a fail on a failure state? Is that what that is? 5126. Air handler. Okay. 26. Nope. I want this guy. Disk save error. Yep. Okay. Label adder 5147. Name BB screen save error. This one is just like the reset, I think, right? Screen check disk. Yeah. Label 5 adder 5156 name. Maybe next. Okay. Hang on. How does Mist handle saves? How the hell does that work? Yeah, just save error. That's not the button I want to press. Get out of there. How do you recover from a disk save error? What the hell? Hold on, does it just kill itself? Eject. Got it. Got it. Got it. That's fair. Okay. Now then, where does This gets saved. Less than 2 saves? Maybe. No. No. It doesn't get saved over here. What the fuck? I'm not sure what this is. Am I gonna have to actually fucking write this to disk on hardware and then dump that? I am, aren't I? Oh, damn it. I don't want to do that right now. I don't want to do that right now. Files in his local directory. Nope. That's where it would have been, right here. This is where I'm running it from. I don't think that's current. Set Teleview. Okay. I didn't know it implemented that. Power for closing it? What? God damn it. Yeah. An IPS. What the fuck is an IPS file? The hell is that? All right, so I'm going to go over to here. Patch file. God damn it. We're going to copy config mess and over the SN2. That's I suppose. SN2 saves. Souseiki Fammy BB RAM into ROMs. God. So how the hell do I patch this now? I don't know how the fuck this works. Patch. How do I apply an IPS patch to a file? Flips? Oh, yeah, okay. floating IPS. Okay. Apply exact BPS. Out ROM. Create. Okay. Apply IPS, BPS, or UPS patch default if given 2 arguments. Create an IPS or BPS default given 3 arguments. Info. Okay. Bit of a verbose disassemble the entire patch. Fantastic. Create this patch. No. Exact. Do not remove SMC headers when applying or creating a patch. Not recommended. May affect patch compatibility. Okay. Yeah, apparently not. Yeah. Ignore checksum. BPS only. Manifest BPS only. Emit or insert a manifest file exactly here. Nope. Okay, so SF BB RAM save dot IPS, because that'd be easier to type out. Okay, so flips, apply, save IPS. This is gonna be on top of the BB SF BB RAM dot FDS. Okay. Okay. So Pixel, how you doing? Am I working on a game? Not quite. I am working on reverse engineering some stuff. How you doing? Welcome, welcome. All right, so let's get this into the make file. Vim make make file. Okay. So, ROMs SF BB RAM underscore save dot FDS. We're gonna need SF BB RAM dot F save dot IPS. Oops. As well as that dot FDS. Flips. Apply all those guys, and put it there. File 1. Bin. How are the decompilers for the NES? So the one I'm using right now is part of the CC65 compiler suite, called DA65, and it works fairly well. It's not a smart decompiler, disassembler rather. It's a kind of a dumb one, but it takes a bunch of configuration options, which is fine, right? And a smart disassembler wouldn't handle what I'm disassembling very well anyway, because there's a bunch of self-modifying code littered throughout this code base, and that's atrocious. But whatever. Dot. Oh god, this is gonna have another like, oh, we're gonna copy this to whatever. So this is gonna be the fucking pre-copy, because everything's pre and post copy. Everything is. I don't need all that. DASM. I only need this actually. Yoink. And then bins this guy. Like that. Get rid of that. And then hang on. SP ESF BB RAM save pre copy dot kfg. Yeah, auto disassembling this is not really a thing that'll happen. ROMs SF BB RAM save dot FES. Right, it's file 1. That's what I need. I need the file 1 designation here. That should actually just work, honestly. I have to tell it that I want that, though. No rule to make target IPS. Oh, because that's not where that is. ROMs. There we go. That. Okay, wait a minute. Why didn't it, hang on. Should that have, It did. It did put labels on the end of it. Why? Labels wrong? Oh, no, because I... B8. B8. There we go. That's better. There we go. IPS files for FDS and flash saving is a bad implementation. There's absolutely no file name or integrity check in the format itself to prevent corruption. Yeah. I was curious how Messon handled writing to disks, and I hate it. I hate it. I want to look at the syntax for pipe operators in other languages. Looking at images, half are what you'd expect. The other half are people working on pipes. Okay, so this is that empty thing. Pre-copy. Empty vector. And then D0. Oh, that's somewhere else. Okay. I don't know why I wrote that one. I won't write that one. Empty vector all over the place. And this guy here is the entry point. DFD0. Name BB pre-copy entry. That is going to copy some bullshit around. Yeah, because it jumps to 5100 there. All right. Yes, this is a straight copy then. Range, a straight simple copy without anything else. B800 end DFD. No, EF. Type byte table. Puppet. Nope. DFCF. There we go. Okay. Range start DFD0 end DFEB type code. That's what the message assumes that it's only used for saved data, which I believe it also saves as raw data without any integrity checks. Painful development builds, yeah. It's almost as if FDS R&D is unpopular. All right. All right, so this is the outer loop. Label adder DF D5 DF D7 outer inner, yep, and then really? Did I not have anything in there? Maybe not. Yeah. I don't think it actually loads anything into 6000 if I don't. Well, for just the save, right? Yeah, actually, it wouldn't. Right? It'd leave that alone because I know I can't use it. See, all zeros, I guess, is correct. All right. SF BB RAM save post copy. Yoink. Paste. Start address 51. Input offsets 800. Make file. No. No. That is incorrect. That's the start right there. What the fuck happened? It doesn't start at oh my god. It starts at B8, not D8, so I need to offset more. Okay. Hex D8 minus B8. Okay. There we go. That's better. That's better. That's better. Label. Adder 5100. Name. BB. Save entry. Or post copy entry. Huh? Oh, because it... Yep. Range. Start. 51E0. And 51E4. Type code. The fuck? No, that's not. Huh? 51EB. Start 51EB. End 51F6. Type byte table. It's better. All it does is write the ROM back to SRAM and reset the ROM. Yeah. No. So this guy. That's 51E0. BB FDS reset IO. Turn on the LED. Okay, yep. Just, oh boy, here's the transfer routine. Right? 514B. Oh, I need Yep, there's a transfer routine. 512B, 512B right there. And there's 8 of them. Range, start. 512B. Not entirely sure how big this is, so I can go down to there. 514A. 514A. Type byte code. Not byte code. Table. Somebody must be. Oh. 52. No, wait. 514A. Five one two B. One, two, three, 4, 5, 6. Huh? 4 byte? 4 byte. One, two, three, 4, 5, 6, 7, 8. 4 byte. Label. Adder. 5124. Name. Do X fur. Just a little bounce. What is this? Dumb as hell, but sure. 511E. BB. Clear reg. And 20. Set reg. So those are. This is all the transfer stuff. Range. Start. 514B. End. One DF. Type code. There we go. Yeah, so this one's a little bit more straightforward. So yeah, so this copies from 5.8 to B8. B8? No, B8 to 5.8. Then 5.8 to 60. Then C0 to 5.8. Then 5.8 to 68. Then C8 to 5.8. And 5.8 to 70. And D0 to 5.8. And then 5.8 to 87. Or 78. All right. B8. Yeah, so that's Yep. That's that first bit of that file. So they just contain it in a single file. I feel like it'd make more sense to have that as its own file or something, you know? What the hell do I know? And then there's all this bullshit that is never used in this ROM. None of that's used. Look at all that wasted fucking space. Look at all of it. So much wasted goddamn space. Doesn't make any sense to me. I am so very tempted to attempt to rewrite all these discs into one disc. So tempted. Because there's so much reused code. It won't be tonight. Yeah. What I have to do first is get more comfortable with just making FDS stuff. It doesn't do any crazy bullshit, right? Get comfortable with just the disk system. And then from there, start doing the crazy bullshit. And I may end up trying to figure out how to patch in the Souseiki Fammy into Messen. Like proper. I was looking at it earlier today of like when you load a ROM, what does Messen do? Like what does it do when it, you know, because I know it obviously clears out RAM. So I need a way to disable that. So I'm following the code path of like, all right, load has been clicked. Where does it go? And how does it figure out where to get, right? So I don't know if I want to take that path or or if I want to flesh out my own emulator more to be actually usable as an emulator. A long ways for that, but I think I might want to go that route. So I would need to, for this stuff anyway, I would need to at least emulate the PPU as well. I'm not interested right now in doing APU stuff, audio stuff, but I might. I'm getting closer and closer to writing PPU emulation. Which means I have to make some stuff a bit more cycle accurate. Or rather, I would make the emulator cycle accurate. As accurate as I can. Yeah. Yeah, the idea being as accurate to hardware as possible. But that's a little ways off, I think. But who knows? Maybe next week I'll start working on that. Next weekend. I don't know. Anyway, I think I'm gonna wrap up tonight. We got pretty far. That's good because anything else just ends up being patch upon patch of ROM specific fixes. Yeah. Patch upon patch upon patch. Yeah, and seeing how Messen handles the FDS, specifically around like disks and whatnot. I want to completely change that workflow, right? Because again, with Messen, it's like, all right, you load a disk, and that's the only disk you get, right? If you load another disk, it resets the emulator, which is not how the disk system works at all. at all. Yeah. Yeah, the way it's been handled with multiple disc games was just like, oh, all 4 discs or whatever are in one FDS file, just as different sides, and that's just like, no, ew, what are you doing, huh? Absolutely not. I don't like that. Other disc and new disc, yeah, exactly, other disc, new disc, right? A blank disc, give me a blank disc, right? That and I'd want to be able to be like, oh, we're running this the Souseiki Fammy, so we're gonna insert a cartridge too, just cause fuck it. But there's some display stuff that I need to figure out, some UI stuff I need to figure out. Probably gonna do some of that stuff off stream. And then once I figure out what I'm doing or how I'm gonna do it, then I'll do that probably on stream. Yeah. Wasn't there something about the FDS being unable to write that header on a fresh disk? Really? I wouldn't be surprised if the BIOS disallows that. Yeah. But the disk, the system itself presumably can, because I mean that's like one of the functions of this guy, right? Yeah, the drive itself is a dumb drive, so the drive itself doesn't give a shit, but the BIOS does. The BIOS cares, because that's copy protection stuff, right? So if you circumvent the copy protection and just do your own thing, I don't know. Anyway, let's see who's live. I need to wrap up tonight though. Let's see who's live. We can go say hi. Go rate them. Biggest part of getting most of the Fammy chargers working without loading an extra cart shouldn't be too hard to patch into Messin, but adding the cart, I'm not so sure about. Yeah. There are multiple versions of the drive PSU and controller boards, all for copy protection. Ooh, maybe not. Okay, I was wrong. All right. So I know that there's the length on a write, right? Like you can't write sustained for a certain amount of time, or else it'll interrupt it or something like that, right? As far as the others, I wasn't aware of that. All right, who's live? And again, I am kind of new to the disc system scene, if I'm being honest. Vulcan shenanigans, what the heck? But yeah, so I was looking at Vulcan bindings the other day for Go, specifically for my emulator stuff. So I don't know if I want to do that or like SDL3. But I needed to try out some stuff, see how things work with a PPU implementation, to see how I can handle that, number one. Let's go over here. Not sure who this is, but come with me to say hi regardless. I really appreciate that. I should be back next weekend. The 2nd. Should. We'll see. Probably doing more related stuff to this. I'm not sure on any specifics. It all depends on what happens this week. Again, thank you for being here. Appreciate it as always. And yeah, I'll see you next time. Okay, bye.